Right, welcome to the second part of lecture date 9. We had to stop in the middle due to a phone call. Right, so we were talking about the case where we have this series of NOT gates together back to back, and the scaling factor is S, where S is a general number, and we want to find out the value of S for which this chain delay is minimum. So, how would you find out the value of S for which this TD is minimum? Just by differentiating this D with respect to S, computing its partial derivative with respect to X on both sides, and putting right hand side equal to 0. Right. This log of CL over CS are S, R, and C are constants compared to S. So we'll take them out of this operator. Log of CL over C times C over R multiplied by R. R multiplied by C times this are constants compared to S, and this operator will apply on this expression. So you're taking this whole on the other side of the equation and dividing it by 0 becomes everything becomes 0. So partial over partial S over log of S is equal to 0. Or it can be written as partial over partial S times S times inverse of log of S equal to 0. Now we have two terms A and B multiplied together, and we have to compute its partial derivatives. That takes us to the case where the first term is written as such. For the second term, we compute a derivative minus 1 over log S squared log S squared times the derivative of log of S is 1 over S plus the second term 1 over log S as such, and the derivative of the first term, which is up 1, is equal to 0. So this takes us to this S cancels with this S, and we can take compute 1 over log S can be written as a common out of the 2, and this becomes minus 1 over log S plus 1 is equal to 0. Multiplying both sides with log of S, we get rid of this 1 over log of S and get rid of these brackets, taking this minus 1 over log S on the other side of the equation is equal to 1. Inverting both sides, log of S is equal to 1, or S is E. This means if we set the scaling factor, the increasing scaling factor S equal to E, which is 2.71828, an irrational number, E, the total chain delay can be minimized. In the upcoming lecture, we'll see further factors to minimize chain delays. Thank you.